Okay, so this is the acid, bases, and salts review for the college prep chemistry. If you're in the honors class, please make sure you're watching your honors video. So make sure you've got your calculator, your reference tables open to page 6 for table K, L, and M, and maybe a scrap sheet of paper in order to do some calculations. And hopefully you've been looking over your notes and you're ready to roll. Okay. Which compound dissolves in water to form an aqueous solution that can conduct electric current? So electric current, okay, that means electrolytes. What is an electrolyte? Those are things that can conduct electric current, and the definitions are anything that are acid, bases, or salt solutions. So that's like the whole point of this unit. What is a salt, by the way? That's ionic compound, and it has to be in solutions that you have mobile ions. So now, back to the question. Which of those is either an acid, base, or a salt? Well, let's take a look at table K and L to help us out. I don't see this anywhere, so that's probably not our answer. I'm just going to do that. I don't see this on table K or L. That's probably not our answer. Number 3, CH3COOH. Hey, I do see that on table K. That's called acetic acid or ethanoic acid, and so that must be our answer. This is not. Yeah. As water is added to a 0.1 molar NaCl aqueous solution, what happens to the conductivity? Okay, so NaCl is ionic. You know that because it's a metal and a nonmetal, and it's in solution, so it's an electrolyte. So we are diluting this. We're adding water. So if I were to give you poison, you would probably get sick or worse very quickly. If I were to give you a diluted poison, it would probably take longer to make you sick, if maybe you wouldn't get sick at all. So your conductivity will decrease because the strength of that will decrease. Your molarity will go down. So it's choice 1. Because as you dilute something, it's not as concentrated, you'll go down. Okay, so we just talked about electrolytes. A substance is classified as an electrolyte because, it is conducting electricity in the aqueous solution. Okay, so we have a 0.1 aqueous solution, 0.1 molar aqueous solution. It conducts electricity. Okay, so already I need an acid, base, or salt. It's going to turn blue litmus red, and it's going to react with zinc to produce gas. So let's wait on those two for a second, and let's take a look. Anything we need is going to be either ionic or on table K or L. So this is not on table K or L. This is ionic, metal and nonmetal, so I'm going to keep that for now. This is not on table K or L, but I know it's an acid because it leads with H+, and it looks like almost all the other ones. And this could be our base, yes. Now, let me actually go back for a second. The difference between CH3OH and LiOH, and I'm going to write that over here. CH3OH and LiOH. One of them is a base and one of them is not. This one is not because it is organic. What does it mean to be organic? Well, you've got carbon. So because it's organic and it has an OH, it's an alcohol. This is called a base. Yes, they both have OH, but because this is what we call inorganic, that means it's not an alcohol. So LiOH is a base. I should get rid of those now. So the other one is not. That's good enough. So this is gone. So now we're down to those two. Oh, those three. Blue litmus turns red. So now we need to look at table M, where we have our indicators. Litmus turning red. Now I know it just says litmus, not blue litmus, but just go ahead and read it. So anything that's red is going to have a low pH, 4.5 or lower. Well, 4.5 or lower, that's an acid because pHs of that low are acids. So who would be an acid? That's choice 3 because we lead with H+. This is a base, this is a salt. Which is a non-electrolyte, which means it's not an acid, it's not a base, and it's not ionic. This is on table K. This is an acid. Nope. This is on table K. It's an acid. And now we're down to those two. Remember this? I just erased it. One of these is a base, and one of these is an alcohol. So if I look on table L, I see that this is a base. So this is an alcohol, meaning that is our non-electrolyte. Which of the following is the best conductor of electricity? So we want acids, bases, or salts. So none of these are on table K or L, so they're not acids or bases, but these are salts. So those are gone. By the way, 3 and 4 are sugars. So wait, they're both NaCl, so which is our answer? The one in which it's aqueous, the one in which we have mobile ions. Salt in the solid phase will not do it. Okay, now we got some definitions. The Arrhenius theory explains the behavior of acids and bases. We have Arrhenius acids and Arrhenius bases. Check your notes. Arrhenius acids are anything that gives off H plus in solution. So here's our question. Which will give off H plus in solution? So there are two things you can do. One, you can go ahead and take a look on table K and see if we see any matches, which we do. We see choice 3. So that's an acid. The other thing we can do is say, well, which of these is going to give off H plus? So we've got BaOH taken twice. That's going to give off Ba plus and OH minus. That's not going to give me H plus. It's going to give me Ba plus, and actually it would be Ba2 plus. This one, that is an organic ester, so that's not going to do anything. There's no pluses or minuses. It's all covalent. Now this is going to give me H plus, actually going to give me 3 of them, and PO4, that's, oh wow, PO4 minus 3. So see how that gives off H plus? This is going to give off Na plus. So that's why our answer is choice 3. You don't have to go through all that extra stuff if you just take a look on table K or L. K for acids. Now, number 9, we're looking for bases. So we're looking for somebody on table L. And I do see KOH on table L. That's our answer. Remember, the difference between these two, they both have hydroxide, the OH, but this K is inorganic, which makes it a base. As soon as you see carbon, that's organic, and that is an alcohol. So that is not what we want. Let's go back up here. What is the only negative ion produced by an Arrhenius base? We were just talking about this. It's OH minus. According to Arrhenius theory of acids, citric acid in oranges and acetic acid in vinegar are classified because their aqueous solution. What is the definition of an Arrhenius acid? It produces hydrogen. Oh wait, is it ions or atoms? Well, if it's H plus, that's an ion. So choice 1. By the way, H plus is also known as a proton. So be aware of that. Okay, now, what is the pH of a solution that has a hydronium ion concentration 100 times greater than a solution with a pH of 4? Now let's back up for a second. Hydronium, if you look it up on table E, is H3O+, which is the same as H plus in water. Okay? So what is H plus? H plus has to do with acid. So these are pretty much the same thing. Okay, because that's aqueous. But back to this. If you have a greater amount of hydronium, that means you are the more acid. So we talked about how on the pH scale, each jump is worth 10. So here's our pH scale, 0 to 14. And here's 4. 1, 2, 3, 4. No, I don't want that right now. You stay. It's not very equal. How about we say 1, 2, 3, 4, 5. No, sorry guys. 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, not super equal, but that's okay. So here we are, 1, 2, 3, 4. I want 100 times more acid. So each jump is worth 10. So pH of 3 is 10. pH of 2 is 10 times 10, which is 100. So pH of 2. Now, that's because we're becoming more acid. If it said 100 times less, that would be moving 1, 2 spots to the right, which would be pH of 6. All right, so number 13. As the pH of a solution is changed from 3 to 6, the concentration of the hydronium atoms, ions, does what? Okay, let's see if I can get rid of that for now. Okay, so, and I'll choose a different color. Boop. 1, 2, 3. So here's 3, 4, 5, 6. So we're going from 3 to 6. Again, hydronium ions means acid. So you know if we're going from 3 to 6, we're decreasing the amount of acid. And that green is obnoxious, so goodbye. So decreases. So we're going 1, 2, 3 spots. So is it a factor of 3? Be careful. No, it's not. Because each jump is worth 10. So this is worth 10 times another 10 times another 10. So that's 10 times 10 times 10, which is 1,000. So the amount of acid is going to decrease by a factor of 1,000. We just talked about this. Look, an hydrogen ion, H+, in aqueous solution, what does it mean to be aqueous? It's H2O, may also be written as what? So let's count them up. 3 H's and an O and a plus, hydronium. Which statement correctly describes a solution with a pH of 9? So pH of 9 is a base, and I just know that because I know pH scale. So if you are a base, you have a higher concentration of hydroxide. So that gets rid of choice 3, and that gets rid of choice 1. So we have a higher concentration of OH minus. And what happens to litmus? Let's take a look at table M. In a base, litmus is going to be blue in those high pHs. So litmus turns blue. So that's probably our answer, but let's just double check. Methyl orange turns red. Nope, can't be that one because red will be a low pH, 3.1 or below that in methyl orange. And that's not what we want. So we want choice 2. Okay, so we've got 3 different pHs. Which of them is increasing H+? So which is becoming more acid? Well, A is pH of 10. That's a base. That's not acid. B is 7, which is neutral. It's half and half. And then C is an acid, so that is the most. So we are increasing this way, so we want A, then B, then C. An aqueous solution becomes more acidic. As an aqueous solution becomes more acidic, what happens to hydroxide? Well, if you become more acid, you're going to have less of hydroxide because that's the base stuff. So decreases. What is the relationship in a pH of 7? Okay, pH of 7 is neutral. So neutral means you have the same amount of acid as base, which is choice 1. Careful, they're not added, and those are not right. Now, I honestly can't remember if I included KW in your notes. I think I did. W just means water. So if water is neutral, that means we have the same H pluses and OH minuses. Don't get too caught up with this, all right? Given the here, if you increase H plus in water, what happens to this? This is another way of saying question 17. That's going to decrease. There are 4 ones in a row. Oh, there are actually 5 ones in a row. Okay. 21. What is the pH of this? Oh no, I want this. Okay. So these questions are no longer on the Regents, so I wouldn't really worry about it. But all you have to do is take your molarity and move your decimal place until you get that whole number 1. So I start here. 1, 2, 3. It's a pH of 3. The H3O plus or hydronium ion concentration is 10 to the minus 4. This solution is. Okay, so again, not on the Regents anymore. I'm going to include it anyway. So if you're 10 to the minus 4, that means you have a pH of 4. You just bring it down. So that gets rid of that, and that gets rid of that. So if you have a pH of 4, are you acid or base? You're acid. Here's another one of those. Looks like we've got 4 zeros and a 1. So this is a 1, 2, 3, 4, 5, pH of 5. pH of this. Okay, so what is CH3COOH? If I take a look on table K, that's an acid. So if you are an acid, I know my pH has to be not greater, not equal. Doesn't have to be less than 1. It has to be between those. An aqueous solution of hydrogen ion concentration, which is 1 times 10 to the minus 8, means I take that 8, negative 8, bring it down to my pH is 8. So if my pH is 8, it's a base. I gotta tell you right now that this section right here, and I'll make it a different color. This section right here might be, no, I'm just gonna say it. This is a little bit beyond what I'm gonna give you on your quiz. So just be okay. You know, if you don't understand it fully, you can certainly ask me questions, but don't stress about that. That's not a most important, definite need to know kind of thing. But table M certainly is, so we need to definitely know about those. Which indicator is blue in a solution that has a pH of 5.6? Okay, so we need table M. Let's remember how to read table M. So for example, here's methyl orange. It says 3.1 to 4.4, and then it says red to yellow. So if I'm looking at this, my pH scale is 0 to 14. So 0 to 3.1 is going to be red. 4.4 to 14 is going to be yellow. But here in the middle, I don't know. It's unknown. So that's how you read them. So 5.6, brome cresol green, 5.6 is on the right, which means it's the color on the right, which is blue, which means that's probably our answer, but let's just go through everything. Okay. Brome thymol blue, 5.6. Yeah, that's below 6, so that's yellow. That's not my answer. Methyl orange, 5.6 is yellow. Thymol blue, yellow. So that's not our answer. So it is indeed choice 1. Which indicator is yellow in a solution with a pH 9.8? So methyl orange, yellow. That's got to be our answer. But I'm just going to double check. Just, make sure. Yellow is below 6, so that's not going to be it. Brome cresol green, yellow is below 3.8. Thymol blue, yellow is below 8. So that is indeed choice 1. How's it going? Oh no. Where did it go? All that stuff is gone? Oh, sorry guys. All right, well, I apologize. According to table M, what is the color of the indicator methyl orange in a solution with pH of 2? Another one of these. Okay, pH of 2, methyl orange. So 2 is on the left side, so that's going to be red. Choice 4. By the way, all the answers to this are attached on that other document. A solution with a pH of 11, whoop, that means base, is first tested with phenolphthalein and then with litmus. What color is each? So I'm going to take a look on table M. I know that a pH of 11 is to the right of the range, so it's going to be pink. So not those. And with litmus, pH of 11 is also on the right, so that's going to be blue. So litmus is blue, choice 3. A student dissolves a substance in water, tests the resulting solution, and observes that red litmus paper turns blue. What is the result? Okay, so litmus changing color has to do with either an acid or base. So take a look on table M. If litmus paper is turning blue, which I know that it says red litmus, but just go with it, okay? On table M, it just says litmus. If litmus turns blue, that's a high pH. It's 8.3 or higher, which means basic. Which particle in water causes NaOH, which particle in a water solution of NaOH causes red litmus to turn blue? So let's just say, what's going to make this turn blue? What particle has to do with base? And that's hydroxide. All right, now we're dealing with Bronsted-Lowry acids and bases. So in a Bronsted-Lowry acid, Bl, Bronsted-Lowry acid, we donate H+, H+. In a Bronsted-Lowry base, and by the way, I'm sorry, this is really hard to read. In a Bronsted-Lowry base, we accept H+. So the forward reaction only goes this way, which means your two choices are NH3 and H2O. So these are not even going to be choices because we're only reading that way. NH3 becomes NH4. What happened? It seems like it gained an H and a plus. So that means that's our answer. H2O becomes OH minus. It lost an H and it became from neutral to negative. So that's giving away. According to the alternative theory, which is Bronsted-Lowry, H2O is considered to be a base when it accepts a proton. Proton is H plus. All right, let's move this down. 34. Which statement describes the behavior of H2O in these reactions? H2O becomes OH minus. So it looks like we lost an H plus, and that is an acid. So X is acid. Water, oh, it has an extra H and a plus. So this water is accepting, which means it's a base. So water is an acid in X and a base in Y. You definitely don't need to know this one. Goodbye to that. Nope. Which concentration includes a basic solution? So bases means you have to have high amounts. So you need to have more than neutral. So that has to be choice 1. See how this is that neutral, that 7? More than neutral would make you a base. Don't worry about 36. Oops, you don't have to do that. In fact, you don't have to do 37 also. Conjugate acid-base pairs. Okay, neutralization reaction is when an acid and a base come together and produce a salt and water. So I'm looking for an acid and a base, and there they are. As an acid solution is added to neutralize a base, what happens to OH minus? So you're already at a base, which means you have a high amount of OH minus. And as you add acid, you're going to lower this to get it to be that 7 or neutral, which is a salt. Okay, so that means you need an ionic compound. It cannot be an acid. It cannot be a base. So this is an acid. Nope. This is an acid. Nope. This is a base. This is considered a salt because we have our Na plus and our NO3, which is minus, and that's an ionic. Okay, now this looks like we have a titration. So let's get our calculators out. Let's get our reference table T. And I am messy here. I do apologize. Doing the best I can. All right, so formula for titration is Ma times Va equals Mb times Vb. Molarity of acid times volume of acid equals molarity of base times volume of base. The tricky part, I think, is assigning who's acid, who's base. Which volume of 0.1 molar NaOH? Okay, what is NaOH? Is that an acid or a base? Well, I'm going to take a look at table L. I see that it is a base. So that's going to be our Mb. So Mb is 0.10. Which volume of that means I don't know that. Call it X. 15 milliliters of 0.20 HNO3. So HNO3 is an acid. It's called nitric acid. So that is our molarity of the base, acid, 0.20. And then this is 15.0. So grabbing my calculator, I'm going to do 0.20 times 15, and that gives me 3. 3 equals 0.1 times x. So divide both sides by 0.1. My cat is trying to get cozy behind me, and she's making lots of noise. 0.3 divided by, 3 divided by 0.1 gives me 30, and that is a choice. A student wishes to determine the concentration of a weak acid by titration with a base of known concentration. What is the most important property of this base? It should be weak, it should be strong, it should be of known molarity, it should not react with carbon dioxide. Well, remember, the whole point is you should only have one molarity that you don't know. You have to know the other one. And since we don't know the concentration of the acid, we have to know the concentration of the base. We have to. Here's another titration. I can just tell. So it looks like we're looking at acids. I know that because HNO3 is an acid determined on table K. So I don't know my molarity of the acid. 16 milliliter sample of 0.50 KOH will completely neutralize 32 milliliters of which acid? So there's that. And then 16 and then 0.50. Now you might notice that I did not put these numbers in the exact same order. This is the volume of the base and this is the molarity of the base. But you should also remember from math that commutative property of multiplication says that you don't care about the order here. 16 times 0.5 is equal to 0.5 times 16. So that's 8. 32x equals 8. Divide both sides by 32. And you get 0.25. That's your answer. So this is a titration using a burette. A diagram shows NaOH being added to the HCl. A few drops of phenolphthalein were added. The end point is reached. Okay, so if you're adding base to the acid, phenolphthalein starts off colorless. And I know that because I look on table M. So it's going to be colorless in any acid, neutral, and super weak base. But as soon as we add enough base, it's going to change. It's going to turn pink. And I can look on table M. Last one, calculation. I'm just going to skip. What is the concentration to an HCl? So that's going to be molarity of the acid. HCl is an acid. I know that, table K. A 9 milliliter sample of HCl is exactly neutralized by 6 milliliters of a 3 molar. And I didn't do the decimal place of zeros. That's all right, I guess. 6 times 3 is 18 equals 9x. Divide both sides by 9. You get 2. Okay, I hope that helped. Like I said, some of these questions are not going to be as stressed. You should definitely know titration. You should definitely know reference table M. Bronsted-Lowry acids or bases, not really. Maybe one question or two. And the theories, Arrhenius, properties, electrolytes, definitely. So I hope this helped. Take care.